In this video, we're going to explore the surface area of pyramids. So first, a definition. A pyramid is a 3D solid with one base and faces that meet at one point. We're going to call that point the vertex. The vertex, we're going to define it as the point where the faces of a pyramid meet. Sometimes that's called the apex of a pyramid. Now, in this next part, we're going to get into some very specific things about different dimensions of the pyramid. One is the altitude. The altitude is generally the height of the pyramid. So if we were to drop a line right from that vertex point straight down, the altitude would be the height of the pyramid, how tall it actually is. Then we have a dimension called the slant height. And the slant height is, if you visualize a pyramid, if you were to walk up the Great Pyramids of Egypt, let's say, that would be the height you would actually walk, the slant height. Now notice that the slant height is going to be bigger, potentially much bigger than the height of the pyramid itself, depending on this little angle down here at the bottom. Now, in a pyramid, there's this relationship here that this segment will be half of the base, whatever the side of the base is. This altitude will be perpendicular to that side, and the slant height will form the hypotenuse of this right triangle. We also have this thing called the lateral edge. That's where the faces of the pyramid are going to meet. Now we have many different types of pyramids, but the two main ones we're going to look at are square pyramids and triangular pyramids. These are examples of square pyramids. Again, the Great Pyramids of Egypt and then pyramids at Chichen Itza are all examples of square pyramids. Triangular pyramids are a little bit different because they have a triangle base versus a square base. But in general, you're looking at triangular faces as well. So let's get into some details here. The square pyramid, the shape of the base is a square, and there's one of them. The triangular pyramid, the shape of the base is a triangle, and there's one of them. But for both of the pyramids, or any pyramid in general, the shape of the face is going to be a triangle. And depending on what the base is, if it's a square, we know that all of those faces are going to be equal. If it's an equilateral triangle, then all of those faces will be equal. And just as in prisms, the number of faces is equal to the number of sides of the base. So the number of lateral faces is equal. So 4 sides, 4 lateral faces. 3 sides, 3 lateral faces. So how many bases does the pyramid have? Always 1. And the faces are always triangles. The relationship between the number of faces and shapes, we've already talked about that. The number of faces is the same as the number of sides of the base. And our procedure for finding a lateral area, in prisms we found all the rectangles that weren't the base. In pyramids we're going to do the same thing, but now we're looking at the triangles that aren't the base. And then for surface area, we're just going to add in whatever the area of that base happens to be to the lateral area to give us a total surface area. So a couple examples. First one here, we have an equilateral triangular pyramid. And I know that because each of these bases is marked off as such. So each side of the base is going to be 6. And notice that we have 3 triangles, one here, and then one around on the back. All of them have the same slant height of 10. So if we can find the area of one of the triangles, because it's an equilateral triangular base, all 3 are the same, then we can find the lateral area. So each triangle is going to have dimensions of base of 6 and a height of 10. We can find the area by doing 6 times 10 and then half of that. But again, there are 3 of them, so when we multiply all that together, we end up getting 90 square centimeters. For the surface area, then, we have to add in, there's one base, not like a prism where there's 2. There's one base that we have to add in. And that base is a side of 6. So we take 6 squared, which is 36, divide that by 4 is 9. And we got 9 root 3, which we're going to add to 90. So our final answer is 90 plus 9 root 3 centimeters squared. Notice we didn't put those together. They're not like terms. Same idea in a square pyramid. But instead of having 3 triangular faces, now we're going to have 4. But the fact that it's a square shows us that every side of the base is equal. So we have 16s all the way around, which also tells us then that every single one of the triangular faces must have those same dimensions of 16 by 17. The 15 is just there. It's nice information, but we don't need it to solve the problem when we're dealing with surface area. If we were talking about volume, absolutely, we would need the 15, but we're not there yet. So to find the lateral area, you find the area of one triangular face, a base of 16, a height of 17, 1/2 of that, and there's 4 of them, so we end up getting 544 square inches. And for the surface area then, we're going to add in our square base. So to 544, we're going to add 16 squared, just happens to be 256, put them together, and we get 800 square inches. So again, the shape of the base will tell you how many equal triangles you have. Even if we looked at a rectangle, we notice that we wouldn't have 4 that were the same, we would have 2 and 2. 2 pairs of 2 that would be equal. Okay? So I think that's really the key to this, and again, all those triangles, add them up, gives you your lateral area, add in your base, and then you've got your total surface area.